morning. I am Harini, teaching assistant from Department of Costume Design and Fashion in AJK College of Arts and Science, Coimbatore. Today we are going to discuss about the post-yarn process. What is a yarn? Yarn is a material made from staple fiber or continuous filaments used to make fabrics, sweaters, scarves, sewing garments. Knitting and weaving factories depend on yarn to produce textiles. Sweater factories also totally depend on yarns to make sweaters. Besides, in our daily life, it has a variety of uses like sewing, crocheting, etc. Yarn can be made from cotton, polyester, silk, nylon, wool, etc. Now we can see how the yarns are made. Textile yarn is created through a process called spinning, which can be completed by machine or by hand using natural or synthetic fibers and filaments. A fiber is any substance that can be processed into a fabric. Most fibers are short pieces of hair or material that are woven into filaments. A filament is a long strand of a single substance. When fibers and filaments are woven together, they create a type of yarn called thread. Yarn is an interlocked thread-like material created by spinning several filaments and threads together. Thread is lighter weight than yarn and can be used to sew pieces of fabric together, while yarn is used to make entirely new piece of fabric. Now we can see about the types of yarn. First one is stable or spun yarn. Spun yarn is nothing but short fibers, filament yarn. Next one is filament yarn. Spun yarn or staple yarn. Spun yarns are composed of short stable fibers or long filament fibers that can be cut into short stable fibers. Spun yarns may contain a single type of fiber or be a blend of various types. Combining synthetic fibers with natural fiber is very common. For example, cotton can be combined to or blended with polyester to make polycotton yarns. Next one is filament yarns. Majority of the filament yarns are extruded yarns that are made up of natural extruded fibers or manufactured fibers extruded through the spinneret. These filament fibers are broadly classified into two types, that is monofilament and multifilament. Now we can see about what is monofilament yarn. Monofilament yarn is made from a single or relatively thicker filament fiber, transparent sewing thread, metallic yarns, bare elastic and fishing lines are the example of monofilament yarns. Silk is too fine to be used as a monofilament yarn. Next one is multi-filament yarn. Multi-yarn is made from multiple filament fibers. Continuous filament fibers requires little or no twisting to hold the multiple yarn together. Next we can see about the yarn classification. The yarn is classified into simple yarn or novelty yarns or textured yarns. The simple yarn is further classified into single yarn, ply yarn, cord or cable yarn, and the last one is double yarn. Next, second one is novelty yarn is further classified into slub yarn, spiral yarn, pouncil, loop, curl yarns, knob, knot, spot yarns, chinley yarns, corkscrew yarn, etc. Next, the third one is textured yarns. The textured yarns is further classified into sketch yarns and bulk yarns. The sketch yarns are further classified into heat set thermoplastic yarns, bicomponent yarns, biconstituent yarns, chemical treated natural fibers. The bulk yarns are classified into high bulk yarns, loop bulk or air-jet yarns. The simple yarn is further classified into single yarn. What is single yarn? Single yarn made from a group of filaments or staple fibers twisted together. If untwisted, it will separate into the individual fibers. The next one is ply yarn. Ply yarn comes under the simple yarn classification. Two or more single yarns are twisted together to make a single yarn. If the ply yarn is untwisted, it will separate into a single yarn which will separate it into individual fibers. Next one is cord yarn. Two or more ply yarns are twisted together to form the cord yarns. Rope yarns. Two or more cord yarns are twisted together to form the rope yarns. Next one is yarn twist. In yarn twist, we can see about the direction of twist. When fibers are twisted to make a yarn, they are twisted to the right or left. This twisting is called S or Z twist. The direction of the twist does not usually affect the characteristic of the yarn or fabric. Next is twist per inch. The number of twists per inch can in plied yarns be determined by counting the number of pumps in 1 inch and divide by the number of singles, that is the strands plied together to make the yarn. Next we can see about the amount of twists to be given to the yarn. Twist is needed in yarn to hold the fibers together and is added in both spinning and plying process. The amount of twist varies on the fiber, thickness of yarn, preparation of fiber, manner of spinning and the desired result. The amount of twist affects the characteristic and properties of a yarn. That means the amount of twist can also affect the yarn. Generally, higher twists create yarns that are stronger, more fringe, smaller in diameter, smoother, resistant to snagging and abrasion, resilient, good conductors of heat. The lower twist yarns create weaker, softer, larger in diameter, fusy, prone to snag and abrade, crush easily, resistance to heat transfer. Now we can see about the novelty yarns. Novelty yarns are nothing but the fancy yarns. Novelty yarns are made to create decorative effects in the fabrics into which they are woven. Based on their purpose, each strand is referred as base, core, effect or binder. Novelty, fancy and decorative yarns are used in both woven and knitted fabrics. Knots, snarls, loops and other irregularities can be introduced to create textured surface effects. The effect you can be held in place with a binding yarn. Fancy yarns can be natural or man-made or a combination of both. Two or more threads of different softness, thickness, weight, color and fiber content can be twisted together. Next we can see about the bouncing yarn. Bounce is nothing but kimp and loop yarn, that is bounce and kimp and loop yarns. These yarns are made by feeding one or more effect yarns faster than the core yarn while spinning. Bounce has a hard twisted core yarn. The effect yarn is rapidly twisted around the core so that the excess yarn forms an irregular, wavy, bumpy surface. Kimp is much the same as bouncer, but the excess yarn forms a more regular surface. Loop yarns. Loop yarns is the result of the excess soft spun yarn being formed into well-shaped circular loops on the hard spun yarn. Next we can see about the snarl yarn. Snarl yarn are made in a similar way to the loop yarns, except the effect yarn has a high lively twist so that the excess bits and the double upon themselves and twist together. Next we can see about the knob or button yarn. These yarns are also made by feeding the yarns at different rates while spinning. But this time the excess yarn of one or more of the components form bounces. This can be a regular or irregular intervals. Next we can see about the slub yarns. These are all the fancy yarns. Slub yarns is characterized by having alternating short places of thin frim twist yarn with places of very thick and loose twist yarn. The different areas can be at regular or irregular intervals. Next we can see about moral yarn. Moral yarn are made by twisting together two or more ends of different colored yarns. The effect pattern is one of the regular diagonal stripes of each other. Next is spiral or corkscrew yarn. These are plied yarns where one yarn wraps and the other rather than the yarn being twisted together. A spiral yarn has a higher twist than the corkscrew yarn. A spiral yarn usually has a thinner yarn wrapped around the thicker core. A corkscrew yarn has a softer, bulkier yarn wrapped around a thin frim yarn. Next we can see about the chinley yarns. Chinley yarns have a soft, fusy cut pile which is bound to a core. These yarns can be spun, but the machinery required is much specialized. For this reason, these yarns are usually woven on a loom. The effect yarn forms the wrap which is bound by a weft thread. The weft thread is spaced out at a distance of twice the required length of pile. The warp is then cut halfway between each weft thread. Next, textured yarns and types. Textured yarn is a type of yarn that is created by modifying the surface of the yarn in some way, which gives it a distinctive texture or feel. This can be achieved through a number of different techniques including twisting, crimping or heat setting. There are two main types of textured yarns, that is first one is stretch yarns and the second one is bulk yarns. Now we can see about the stretch yarns. The two fibers most widely used in making stretch yarns are nylon and polyester. Yarn with similar or greater elastic stretch can also be produced using an elastometric thread as a core and wrapping it with a non-stretch textile fiber bundle, filament or staple. Bulk yarns. Bulk yarns are softer and much pliable than tightly constructed twist yarns. Bulk yarns also have better cover. Less transparent fabrics are created by bulk yarns and are of two types. They are high bulk yarns and loop bulk or air jet yarns. Next, we can see about the sewing threads. Sewing thread is a yarn used to combine two or more fabric pieces together in garments, accessories and other textile products. Thread may be comprised of some same construction and fiber content as the garment, but it is often different. Next, we can see about the functional requirements of the sewing threads. The first one is tensile strength. What is tensile strength? Sewing thread should have high tendency with moderate tension. For better loop formation characteristics, the elastic modulus of the sewing thread should be high. The next one is friction. There should be uniformity of friction over long length. Factors are responsible for giving maximum possible tension fluctuation of the yarn components in the cross section and the length. The third one is serviceability. During sewing threads are subjected to abrasion over needles and fabric threads. There is a loss of strength during and after sewing. Sewing thread should have high abrasion resistance so that loss strength is minimum. The next one is aesthetic. Color, shade, luster, smoothness, fitness are some of the aesthetic related characteristics of sewing threads. Certain amount of hairiness in sewing thread has to be positive effect on sewing, but this effect has to be sacrificed for appearance. The next one is cost consideration. From the raw material aspect, sewing thread of natural silk is expensive. A higher melting sewing thread may be expensive, but it should have a judicious use in it. The sense that the fabric for which it is used should also have a high melting point, as the hot needles not only attack the sewing thread but the fabric. Also, the fabric also gets affected. The other sewing thread properties are, in addition to the essential properties, some of the applications may be required for the sewing threads to have special properties like resistance to fluxing in seams in shoes, discontinuous surface to provide grip, and avoid slippage in the seam for high seam strength applications. Next, sewing thread types according to the constructions. First one is coarse span. Coarse span is the best general purpose apparel sewing threads available in the market. Coarse span combines the strength and elongation characteristics of the continuous filament core with the sewing performance and the surface characteristics of the spun fiber threads. The next one is the filament component is merged with the staple fibers in the yarn spinning operation. The filament takes up its position in the center of the yarn with a protective sheath of staple fibers wrapped around it. These composite yarns are twisted to form a pile thread. The next one is the two main horseman construction are polyester filament yarns covered and protected by polyester fibers or polyester filament yarns covered and protected by the cotton fibers. Staple spun polyester thread manufactured from high tenacity staple fibers. The next one is mercerized threads are treated under tension in a solution of caustic soda, which causes the fibers to swell and become rounder in the core section. This process changes the luster and increases the strength of the fibers. The dye affinity is also enhanced by this process. The next is glazed cotton thread are produced from soft cotton threads by giving them a polishing treatment. This process applies a coating of starch to the surface of the thread, brushes the fiber ends into the body of the thread and dries them to form smooth surface on the thread. The next one is continuous filament threads. Coats produce a variety of different continuous filament threads with different physical characteristics which satisfy particular sectors of the sewing thread industry. The continuous filament threads produced by coats are made from polyamide, that is nylon, then polyester and rayon. Next, some varieties of continuous filament threads are: in the production of continuous filament yarn, the filaments are gathered from the spinneret into a continuous strand. Each strand comprises a specific number of filaments depending on the desired characteristics. These strands are then combined and twisted conventionally into plied constructions similar to the post-spinning process used for spun threads. Some of these threads are given an additional process called bonding. In this case, the threads are coated with a soluble resin like nylon or polyurethane. For continuous filament polyester, the resin is cured and dried, which has the effect of holding the plies together. The application of the bonding agents also reduces the abrasion on the thread during the sewing operations. The next one is tribord polyester. Trilobal polyester is a specific type of continuous filament polyester mainly used for embroidery thread. The trilobal polyester has been modified to maximize the luster of the thread created by the individual filaments having a triangular cross section. Continuous filament threads are modified by further processing to produce what we now call textured threads. This can be produced from nylon, that is textured nylon, or we can call it as TXN, or from polyester, that is textured polyester, or we can call it as TXP. The locked filament polyester threads have many of the characteristics and the performance of threads produced by conventional spinning and twisting routes, but the thread does not have a different handle or feel to it. Next is doubling and twisting. The process of twisting is an indispensable means of improving certain yarn properties and satisfying textile requirements that cannot be fulfilled by the single yarn. The method of twisting two or more single yarn is called doubling or folding or ply twisting. Next, we can see about the objectives of doubling and twisting. The objectives of doubling and twisting give the yarn more stronger and more regular yarn, novelty and fancy effect. Then the next one is yarn for different purposes. Next is doubling and twisting are two separate operations. Types of doubling, that is ring doubling machine and 2-for-1 twisting machine. What is ring doubling machine? Ring doubling process is one stage process. Two or more yarn packages are twisted together. The twisting system is the same as the ring frame. Next one is 2-for-1 twist machine. This is a two-stage process. In the first stage, two or more individual yarn are grouped or combined together with the help of a parallel yarn winding machine. Now a definite amount of twist is inserted into the yarn. The next one is Doubling, the ring-spun yarn contains various foils which are required to be removed first on the winding machine and also at winding necessary to convert small packages into larger packages. Bigger packages form contain uniform yarns. Basically, it means several uniform drawn yarns are combined and wound on a package uniformly. Doubling is an ancillary process where double or cable yarn is prepared for processing on twisters. Also in the doubling process, the yarn is also cleaned from lint and waste and the weak and thicker sections are removed and the yarn is cross-wound on a cylindrical bobbin in order to make further processing easier. The next is twist and twist direction effects. As per the twist direction in a single and in doubling, the yarn are known as twist on twist or weft on twist, etc. The single yarns are usually manufactured for warp-way twist, that is Z-way, and the general doubling yarns are weft-way twist or S-way, and such double yarns is known as S on Z. These yarns have good luster, fullness, smoothness and are stable. In order to get special effects, Z-on-Z yarns can also be produced such as wild and crepe etc. These yarns are unstable, harsh and rough. In doubling yarns, the twist factors are generally high and they have different relationship in comparison with their component single yarns for getting maximum effects. The next is Z on Z and S on Z. In Z on Z yarns, where single yarns are low twisted, the resultant double yarns, even with low doubling twist, is fairly stronger and production of such yarns are always economical. Where doubling twist factors are less than 5, Z on Z yarns are always stronger. These yarns are more sensitive to changes of doubling twist than S on Z, as Z on Z yarns have more extensibility than corresponding S on Z. However, they have higher contraction or takeoff. It should be noted that any processing subsequent to doubling that puts high tension to the yarn, it is likely to sustain this tension due to the strength and extension of Z on Z yarns to a greater extent than yarns on S on Z. Next we can see about the properties of double or folded yarn. As the double yarn are voluminous, that is bulky, round and fuller, that means the fabric produced with this yarn will have better cover. Yarn property may affect by the tension variations such as low doubling. Tension results in the higher yarn extension property, whereas increase in tension leads to stronger yarn with reduced extension. However, snarling tendency increases with increase in yarn luster. Several double yarns has tendency to untwist and snarl. To overcome this problem, certain ratio of twist between single and double yarn is required to be maintained. The twist yarns and fabrics which are produced from double yarn show more evenness. With the twist double yarn, a softer and pleasant fabric feel can be obtained. Fabric prepared from twisted yarns are more durable and resistant to chafing. Twist double yarn give higher dimensional stability to the fabric. Special twisted yarn can be produced, required specific effect and character. Next we can see about the yarn count. What is yarn count? Count is a numerical expression which expresses coarseness or fineness of yarn. It means that the yarn count refers how much a yarn is finer or coarse. The yarn count number indicates the length of yarn in relation to the weight. But according to the Textile Institute, they define yarn count as count, a number indicating the mass per unit length or length per unit mass of a yarn. Yarn count is also known as yarn number or linear density. Yarn count measurement system. The different system or units are used to measuring the yarn count or yarn numbering, which mostly depends on the material used for preparing the yarn and the area where it was manufactured. Yarn count measured system can be grouped as the following categories. The first one is analytical system and instrumental system. Now we can say about the analytical system. Actually, this process is consisting with some other systems based on several calculations, and this is why it is called analytical systems. The systems are including the direct system and indirect system. That is, the analytical system includes direct and indirect system. Now we can see about the direct system. In this process, the count is based on the number of weight units in a length unit. Thus, the size or bulkiness of the yarn is directly proportional to the count number. A coarser yarn will have a higher count number, while a finer yarn will have a lower count number. The system used for very fine and very coarse yarns. This system is mostly used for silk, jute, etc. Two important things that is required for this are the weight and the length. Here we will use text, DTEX and denier. The text is equal to weight divided by length into 1000. The DTEX formula is weight divided by length into 10,000. The denier formula is weight divided by length into 9000. For example, 220 divided by 2 DTEX. The 220 is yarn count of one single ply. In direct system, bigger the number, thicker the yarn. Tex and DTEX is used for artificial and synthetic yarns. Denier is used for continuous filament yarns. The next one is indirect system. In this system, the count of yarn expresses the number of length units in one weight unit. Higher the count, finer is the yarn. This system is generally used for cotton, worsted, woolen, linen, etc. The indirect system covers the majority of the important type of yarns. The count is based on the number of length units in one weight unit. This important thing is weight and length. Here we will use English number, that is NE. The next is metric number, that is NM. The next one is linear number. English number is used for cotton. Matrix number is used for wool. For example, 2 divided by 60 nm. Here 2 is the ply and 60 is the yarn count of a single ply. The NE formula is length divided by width into 0.59. The NM formula is L divided by W into 1. Here bigger the number, thinner the yarn. The next one is instrumental system. By this process, count of yarn is measured by using different sorts of instruments where any kind of calculations is not needed and we can get directly the yarn count. The machine which are mostly used for this count are, first one is Beasley's balance, the next one is wrap reel balance, the next one is quadrant balance, and the last one is stub yarn balance. Now we can see about the Beasley's balance. When a cotton yarn is supplied in short length or removed from fabric, the count of yarn can be measured by a special type of balance is called Beasley's balance. The next one is wrap reel balance. By this standard method of count testing, the count of any type of yarn can be calculated. In this system, yarn is measured by the wrap reel counter. In case of cotton, the circumference of wrap reel is 1 yard and required yarn is 120 yards. Again, in case of jute, wrap reel circumference is 2.5 yards and required yarn is 300 yards. The next one is quadrant balance. Quadrant balance is one type of typical balance. This is direct reading instrument. The count can be directly measured from quadrant balance. The last one is stub yarn balance. Stub yarn balance is also worked on the basis of fixed length and fixed weight as like a Beasley's balance, and it is used to find the count of fabric sample. Here the number of fixed weight yarn gives the count of yarn. Thank you.